and I didn't realize it was past the start time. So I'll just tell you a quick story. I flew overnight from San Francisco. I was just doing presentations at Java 1 all this week. Had my last one yesterday from 4 to 5, and then had to do a bunch of interviews with the Brazilians, because the Brazilians want to talk to you and video you the whole time. Did all that, flew all throughout the night, landed at about 9 a.m., drove over here, got here for Angela's talk, and I have not slept in a long period of time, nor have I even had a chance to go home at this point. So if I seem a little bit kind of wired, I've done a lot of caffeine. And we're going to be moving kind of fast in this session. I really appreciate what Buck was up here doing earlier. I actually can demo for you if it works for me right now. I'm circuit breaker as an example, because I think that's an incredibly important, powerful concept as you start approaching things like microservices. So we'll try to walk you through as much stuff as we can. I have a bunch of slides, but also a bunch of demos that I'll show you. We'll see which of them will run for me at this point. My name is Burr Stutter. You can follow me on Twitter at Burr Stutter. That's Burr, S-U-T-T-E-R. Burr at Red Hat, so with a name like Burr, it's easy to get your name, right? Pretty easy. And then you can see that I represent a certain group within Red Hat. Red Hat, of course, is like an 8,000 person organization at this point, over $2 billion. Selling free software is actually working out relatively well. I've been doing it for about 10 years. I was part of the JBoss team out of Atlanta. When they acquired us, I stayed in Atlanta for a number of years, but moved up to Raleigh and live in the Wake Forest area here over the last few years. And my journey started with open source in the very early 2000s. I was doing a lot of Java work and .NET work at the time. But then it started with things like Apache struts in the Java community. Then we saw Spring and we saw Hibernate. And I was also the president of the Atlanta Java user group for many, many years, and the founder of the Dead Nexus conference. And I also helped start the International Association of Software Architects chapter down in Atlanta. So I've been very involved with the community, and my new job is to go out and talk to people on a regular basis. So I've been doing that for the last year. I'm finishing up a 3-week road trip. I did Vietnam, Seattle, San Francisco, get to be home for a couple weeks, and I got to do the Ukraine, Romania, Prague. And so that's kind of what my life looks like now, talking to folks. So let's dive right in. If you go to developersdirect.com, we actually have a book that's no longer on the homepage, so you have to look for it, that walks you through some basic microservices tutorials that specifically cover Spring Boot, Wildfly Swarm, and Drop Wizard. Drop Wizard came first, in case anyone asked you. It was the first folks to do the fat jar. The idea is you take the Java programming model, you stick it into an executable jar, and I can show you what that looks like. It's super simple. And you just deploy a single tiny file to all your servers. And that's the nature of Java-based microservices, and people are super, uber, crazy excited about it. So just keep that in mind. This is the coolest thing ever, that I can take a single individual jar file with all my business logic in it, no application server required, and deploy that from one server to 1,000 servers with a script. And actually what I've done is I've actually deployed about 20 different servers on this laptop, and I'll show you that, because it's that easy to do. Okay? I thought I'd put this in here to kind of give a little context. I've actually been doing software development for a long time. I started in the 80s, and I started with Chewy development. I call it Chewy for character user interface. Specifically, you had a mainframe back then. In my case, it was a Unisys machine, and I did Wiffle on COBOL. Remember Wiffle? Workflow language? I wasn't cool enough to have JCL. We only had Wiffle. And I quickly moved to PCs as well. But then we moved into the GUI world in the 90s. We had to do client server. But my point with this slide right here is to simply say that the world has continued to evolve. And if you just think back a little bit over the course of history, we've had to change a lot as software people, as technologists, as architects. It used to be, back when I started my career 25 plus years ago, the individual could do it all. I was the database administrator, the Novell NetWare administrator. I wrote most of the code, and I had to run it in production. There was no ops teams, per se. There was no network admin. There was no database expert. It was like me and 3 other people, we did it all. And now, to some degree, with microservices, we're coming back to that era, okay? Basically, what I want to be able to tell people, and I have been telling people, is the developer who adopts microservices is now the accountable person again. And I think this is actually important, profound, and required for our industry to succeed. You want accountability again. You don't want to be the developer who can't turn on a machine. Think about that for a second. Are you telling me you can't reboot a server? You need an ops person to do that for you? Yeah, think about that for a second. You can't install software, and developers in enterprise IT can't install software. They can't reboot a machine. And it's almost like they don't know how to any longer. I think that's wrong. Even as architects, right? If you can't reboot a server, maybe you shouldn't be touching the server. But, basic operations, some things like that should still be doable by average people. And in the new world of cloud computing and the new architectures that are out there, it's happening. And since our world is changing to move towards mobile, see, it started with this client-server thing. Then we did this web thing. And then the web thing did Web 2.0 and Ajaxing thing. And then we did APIs, and we did all that. Then we did this mobile thing, and now we're doing this IoT thing. It's just moving along ever faster. Data is no longer, simple things in a relational database structure or hierarchical database or network database. It is now streams of data coming in the form of terabytes of data flowing through our networks, and we're dealing with this fast big data now where we have to apply things like Apache Spark or Apache Kafka and other technologies to ensure that we can even look at the data in some form of semblance of real time and make decisions around that data. We did a demonstration just 2 years ago where literally I gave Bluetooth beacons to 300 people at a conference, and we put Raspberry Pis at different locations at that conference so we would know if you're in this room or the next room. In a single 8-hour, 10-hour window, we tracked over 7 million transactions. We did it all through stream processing. We did Apache Spark to do the analytics, so we would know if you're closer to that sensor, that sensor, or that sensor. And then it all basically showed up on the big screen. And I might even have that video here. Let me see if that video is loaded. I didn't think about it because I'm half asleep. I do have the video open. But this is what it looks like. This is what we showed live the day of, was basically when people showed up at our keynote meeting, keynote room, we showed them this video. And it specifically was, hey, you guys all got here in the morning for breakfast. Okay? And you can see everyone showing up at the top right there for breakfast. You can see the check-in, check-out events. And then after breakfast, they hit all the breakout rooms, which are at the bottom. You can see the breakout rooms down there. You see them back and forth through the breakout rooms. We did this all with about $300 worth of hardware. 7 million transactions in a single day. And then we had our breakout, we had our keynote with all the multi-thousand people had to show up for our keynote in a real big room. And you'll see them show up in the keynote room on the top left. And you can see them all migrating up there. That's when we showed them, hey, we just know you walked in the room. We saw your ball flow in here. Because this was a real-time map. It actually monitored people in real time. And then you'll see them leave the building towards the end of the evening. And I actually took this video at 10 o'clock at night. You'll see them leaving the building and finishing the day. And there'll be a few stragglers in there where we lost track of them or something like that. But we did all that with a couple $100 worth of hardware. So the world is changing. So this is a practical application of IoT. We want to show you to track large things of any sort. We chose to track humans. We had a lot of fun with that. But if you want to track pallets, X-ray machines, anything through a warehouse, anything through a hospital, you know how often hospital equipment gets lost in a hospital? Because you left it in some patient's room, you don't remember where. So this was using Bluetooth technology, not the most practical solution, but it worked. Because the Bluetooth beacons only last about 3 days, but we were able to pull it off. So that's kind of what I mean by this slide here. There's a lot of stuff happening, a lot of cool tech that's coming out all the time. It's getting faster, better, cheaper, and we have to find ways to keep up. And it's hard. It's really hard for me, and I live in this world. And I work in vendor land, where I have the benefit of not having to worry about anything in production. I just can dream up crazy stuff like that demo, and then make it a reality. And I'll show you some more stuff that we have, though, and we'll get right into it. But one thing that I'd like to make a point of here, too, is the vendors that we used to trust have gotten more, there's more vendors, and many of the vendors are gone, too. So now who do we trust? It used to be, buy IBM, we're all good there. But some people brought Unisys and Digital. They had a VAX, right? They had the Unisys machine like I did, the Sperry machine. They might have trusted Novell or Sun, right? Now they're probably thinking things like BlackBerry rollouts. You guys remember when we rolled BlackBerries out to everybody in the enterprise? Yeah, that didn't work out too well, did it? So now you got to be worried about some of these other vendors along the way. And now, think about this now. The people impacting enterprise IT and the way we do architecture, the way we do software more than anybody else at this moment. Netflix. We're taking architectural patterns from Netflix. We're all video on demand people. Think about that for a second. Do you even like Netflix? You're going to say, they're way better than Blockbuster. Well, what happened to them? This is the world we're living in now, and I want you guys to think about that because I think it's quite important, quite profound. Now I'll take my lessons from Amazon, Google, Netflix. Okay? So this is your journey to microservices. This is critical. Some of this was what Buck referred to in his presentation earlier. But if you don't have self-service, on-demand, elastic infrastructure, don't pass go. Go directly to jail until you solve that problem. If it takes your developers 3 weeks to get a new VM provisioned, and I talk to people all the time, they're like, 3 weeks would be fast. It's like 4 for us. And then if I look at you walk through, what are you talking about? We can do it in 3 minutes. It's like, you realize you're special? A lot of people, it's 3 weeks to get a VM so the developer can run a test on a certain piece of code. 3 weeks of wait time. How can you be agile when you're waiting 3 weeks for any resource? Okay? So think about that. So you gotta have some form of elastic infrastructure, okay? You gotta be thinking about DevOps. And I don't mean the marketing BS that you hear out there in the world. You really have to figure out how to get your people, because this is a people problem, it's a cultural problem. You gotta get dev and ops no longer throwing crap over the wall for ops to survive and live with. Dev has to own it production too. They're on the pager now. This is critical in my mind. They gotta be accountable, they have to feel the pain, and once they feel that pain, they solve the pain. I actually ran and managed to develop a team, this is a long time ago, been in Red Hat man 10 years. But I pushed a lot of .NET projects to production. And in one case, we had the proverbial deadline. And by the way, if you guys read the Phoenix Project, if you've not read the Phoenix Project, you must read it. And you need to read it twice. And then again every 6 months after that. And it's easy to read. It's not quite like, like I like reading about dragons and vampires a lot. It's not quite that cool. But it's still pretty cool. It's not quite like a romance novel either. It's actually, it's a fable, it's an allegory, if you will. It's told about a fellow who's in IT ops and has to go solve a problem. The Phoenix Project kills their whole business. And I lived that burden. I took a $5 million piece of business out of production for days because the business demanded that we deploy a product that we knew sucked. And then we did it, just like the Phoenix Project. And so the Phoenix Project, they had to go to handwritten credit card receipts and take point-of-sale transactions by hand. Yeah, we did the same thing for the project I worked on. So these things do happen. And what we found, though, is when developers owned it, were accountable in production, the bugs got fixed faster. I basically had to declare 24-hour cycles so we could monitor and fix the app every night so we could get the business back up and running. And we had to do bug fix Saturdays. We only had to do 2 bug fix Saturdays before developers figured out that they had to work every Saturday until the bugs were gone. Only 2. Then that code got higher quality real fast. It's amazing what happens when you make people actually accountable for their work. And we've taken accountability away from our developers by saying, nope, that's an ops problem. And I think it's fundamentally flawed, fundamentally wrong. But let me not preach on that, let's keep going, okay? All right, so you gotta think about your automation. You can use Puppet, Chef. We, of course, acquired the Ansible team, which were ex-Red Hat people. And you can also look at containers. Docker containers are surely the hottest thing out there right now. And I'm actually running all my microservices in containers. I personally love containers, and Docker containers in particular. You got to be thinking in terms of CI/CD and your deployment pipeline. Continuous integration, continuous delivery. You have more on that later, okay? And then, if you do all that, you're ready to be this monkey. You're ready to build your microservice. Now, here's what's weird. I'm saying all these things, they have a great impact on architecture, they have a great impact on operations, but I can tell you right now, the hottest topic at developer conferences like Java One, I've been to India, New York, San Francisco, Seattle, Vietnam, Ukraine, right? I've been all over the world at this point, and I've got several more of these sessions to do. Developers don't give a crap anymore. They want these microservices. And you know why they want them? Because they feel operations stands in their way. They feel that architecture stands in their way. They're going to be anarchists and break the system. Because if they choose microservices, they no longer have to adhere to your standards. Your WebSphere version 6 on Java 6 running on some old version of Solaris that you've dictated as a standard, yeah, they're going to be done with that. They're going to bring in Spring Boot running on Java 8, and they're going to bring it in a container and blast it right through the organization. This is now happening. The anarchists are revolting and they're winning, okay? I think it's kind of exciting. But if you do all that, you can be the mythical creature known as the unicorn and be like a Silicon Valley startup. We'll keep going though. All right? Martin Fowler says something very similar. You must be this tall to ride this ride. I actually like the concept. Self-service on-demand infrastructure, devs and ops, automation, CI/CD, same kind of concept, deploying pipelines. So if you like Martin's words on this, He says basically the same thing. Okay, we'll keep going. Now, a lot of people think they do continuous integration, especially developers. They're like, hey, do you do continuous integration? Yes, we got Jenkins. Wrong answer. It doesn't matter what tool you use. Continuous integration is a practice, it's a principle, it's a philosophy, if you will. A technology can help you, but you can actually do it without any technology. And so Jez actually has this test. He says, it's real simple, software trunk is always deployable. Always deployable. Your mainline trunk is always deployable at any given moment. If the business says deploy it now, you can deploy it now. You can deploy it 10 times a day, like they say in the Phoenix project if necessary. He also says, everyone must check the trunk daily, at least. So no playing games with feature branches. You got to check the trunk daily. And when it's in trunk, it's ready to deploy. So think about what that requires of your accountability if you got to always be ready to deploy. And that's the mental philosophy of CI. If the build breaks, all hands on deck to fix that build within 10 minutes. How often have you worked in a shop where the build is broken for days, if not weeks? I work at Red Hat. I've seen broken builds for weeks. You got to care about that broken build because it could go to production at any given moment. It really, really matters. As an example, a new engineer can be onboarded in a day with automation. How often does it take a new hire, a new contractor to basically, it takes them a week or her a month to get productive in our shops? Can you spin them up in a couple hours? Should be able to. You can fully automate that experience. And deployment is a low-risk, push-button affair. Low ceremony, we just deploy all the time, every time. We don't even break a sweat, just happens, okay? So it's not about just using Jenkins. Now, on the CD front, continuous delivery. It's about going safely and quickly in a sustainable way. So you should be able to push this at any given moment to production, the software that you've created from trunk that everybody's checked into on a daily basis. It should be ready to go safely, quickly, and in a sustainable way. That's another important aspect. These are things you have to have in order to be ready for microservices. Okay? Your deployment pipeline. What is the purpose of the deployment pipeline? I have a demo of that too, but I don't know if I have it running right now. But the deployment pipeline's purpose is to ensure that the release candidate that's in trunk right now at any given moment is ready or not ready to go to production. That's what the purpose of the deployment pipeline is. And so just keep that one in mind too. And the fundamental thing we're dealing with here in the microservices world is agility. We need greater business agility. We need to meet our customers' needs faster in this world. And that's really critical to what we're trying to do and why the microservices movement has got momentum. I like thinking in terms of digital Darwinism. We're going to see this happening. And so it depends on who you see you study these statistics. These are some interesting ones that come from Lean Enterprise. If you follow that whole genre, right, there was the Lean Startup, the Phoenix Project, Continuous Delivery by Jez Hubbell, and the new book by Jez and that same cadre of people is Lean Enterprise. And Lean Enterprise is really nice if you've not read it because it also talks about how to plan, finance, and otherwise just get the whole enterprise ready to do CI/CD, not just the programming side of it, not just the operational side. And one of the things they talk about in there is the S&P 500 that you know today. A high percentage, like 3/4, could change in a few years. That's the world we're living in now. And if you look at this one, and this particular survey that was done, only 11% of surveyed organizations felt they had the in-house talent and competitive skills. Only 11%. That's all of us here in the room. They don't believe we have the skills, the people that are surveyed here. And we have to figure out how we rise to that occasion. If we feel that we have the skills, we at least got to be heard. Okay? I love this one. So organizations that have transformed, I want to make sure I don't go too far over time, but this is Walmart. And I like Walmart because I worked my way through college at Walmart. I was born in Hawaii. I grew up in Alabama. High school in Hawaii, we learned the program in 1986. Back to Alabama, because it was too expensive to live in Hawaii. And then I went to college at Auburn University, Montgomery. And I had to work my way through 4 years of Walmart to pay for that experience. So I have an appreciation for Walmart from a very low ground level. But also, Ben and Dion, which you guys probably know those names, they're the Jaxians, they did the original server-side.net. I used to have to come to Atlanta and speak a lot to our developers in Atlanta. And at one point, Ben stood on the stage and said, by the way, Walmart acquired my company. And by the way, we're going to turn up, we're a Java shop, and I'm here to speak at a Java conference. We're moving everything to Node.js. This is years ago. So I probably walked up to him after his keynote and I said, what? He's said, yeah, we're moving to Node.js. But Java's, conference you're at. So I bought a plane ticket and I flew out to see him in California, because this is Walmart, California, not Bentonville, Arkansas. They have 2,000 to 3,000 people sitting in Silicon Valley now because they want that level of innovation. And they acquired people like Ben and Dion, who otherwise wouldn't be working at Walmart, if you know what I mean. So they could kick ass and make innovation happen there. And they moved their entire mobile platform to Node.js. They operated at 1% of existing resources on Black Friday, and they pushed a production change to 200 million users on Black Friday. This is an organization that intends to survive this digital transformation. And it's Walmart, right? And you're probably thinking, is it Amazon winning this game? Walmart's coming to play. I like seeing that. And it's an organization I'm familiar with from many, many years ago. Okay? Well, let's just kind of move through some of this, because we got some stuff that's pretty interesting from a demo standpoint. This is a great statistic. The fellow that used to work for Amazon now works for Microsoft, and he goes out there and tells the world, do you realize that based on all the research he's done around A/B testing and other things, that only 1/3 of the features you push in production add positive value for the user and the customer or the business? Only 1/3. 1/3 add no value, 1/3 add negative value. They hurt your user, your customer, your business. So think about that. If we could eliminate 2/3 of the work we do and concentrate on the 1/3 that's right, wow, we could free up 2/3 of our resources right there. That would give us an innovation engine that's going. So that's a pretty interesting statistic, and there's the link there if you want it. Let's see, how much time do we have left here? Not a lot. So what I was doing here is to illustrate the concept of small batches. If you have an organization that moves at 3-month increments, you're only learning at 3-month increments. You're only growing and improving at 3-month increments. We just worked with a bank that does their B2C, so mobile and web, with the B2C API engine. It was all on old school WebSphere, horrible monolithic architecture. They replatformed it all into containers running on Tomcat, running on OpenShift, specifically Kubernetes. And now they can move from 3 months to 1 week, and they deploy every week now. So if the business says zig or zag, they can zig or zag in a 7-day window as opposed to a 3-month window. If they have to fix a production outage problem, like specifically something like Heartbleed or something like that enters the equation, they can patch that in a 7-day window. Do you know how many people are still living with Heartbleed in production? Large number. Because they can't patch their systems even. They don't know if they patch the system or reboot the system, if we even come back up. They have too many Snowflake servers. Okay, we'll keep going here. All right? One thing to note about microservices, it is a style. And by style, you gotta know Zoolander. Okay? There's more to life than being really, 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 really good looking. Because it's a style. And Mark Fowler will tell you, it is like the sexiest, hottest thing ever. And if you want to be part of this, I gotta tell you, microservices are gonna not only make you stronger, faster, but better looking, smarter, get a big raise. This is what developers are hearing and thinking about. So if you have a bunch of developers in your shop, they're going to bring anarchy in because they want this, okay? And people like me are telling them that it's awesome. If you're from the Java EE background, this is the system. Java EE specs this out. You're going to build a system on a JVM running inside an application server, and you're going to have an ear, and you're going to have several wars and dozens, if not hundreds of jars. That's how we do it per spec in the Java land. But you can do it with Ruby on Rails the same way. You can do it with .NET the same way. It's called a monolithic architecture, and it deploys as a single unit. That's what defines a monolith. A single deployment, a single file, if you will, deploying to an application server target. You have a large group of people who basically own that thing. Basically, a large group of developers, operators, DBAs, business analysts, 41 people in this case. And what you're thinking of doing now is breaking that monolithic architecture up into several different microservices with their own independent 2-pizza teams. That's an Amazon thing. That have you build it, you own it. It's a different philosophy. Okay? These individual small teams have to own that particular microservice. So we'll talk more about that in a second, but there's some things I really want to show you. Oh, but yeah, and by the way, if you are in architecture, you saw that slide earlier, like, wait a second, I saw this about 10 years ago. We called that SOA. We installed an ESB. Yeah, you got a lot of ESBs out there, don't you? If you hear ThoughtWorks come, they'll just make fun of you. Oh my God, you have an ESB? The Enterprise Evil Bus? Okay? Because what happened was, think about it for a second. We installed the ESB and a centralized governance model. We then created these cowled druids who are responsible for that. called enterprise architecture in many cases, and they stopped all changes throughout the organization because everything had to be routed through them. You want to make a schema change? Wait in line for 3 months. You want to make a code change? Operational change? Re-architect those servers? Well, you got to get the transformations to work with a central ESB because the business logic's actually in the ESB, not in the systems anymore. So this is why ThoughtWorks doesn't like this architecture. It basically stopped all innovation, and in the case of microservices, your ultimate goal is agility. Conway's law gets discussed there on a regular basis. Basically, if your software architecture will look like your communication model. Okay? If you have an organizational model, this happens at Red Hat, right? If you have an organizational model and a certain hierarchy within an organization, your software architecture starts to reflect it. It's kind of nutty if you think about it, but it happens. Okay? These are all the key principles around microservices. There's only really one that I really care about, and that is deployment independence. Any given microservice, to be defined as a microservice, it doesn't matter how big you are, how small you are, if you can deploy at any given moment, when you need to deploy based on your business directive, you might be a microservice. Deployment independence is what matters most. And so you might be thinking, we can deploy things independently. You probably are deploying whole monolithic architectures independently, like whole things, big systems, but we're talking a small fraction of the application. The best way to see this, though, is in the demo. So let's do that. We don't have a lot of minutes, and I'd rather show you some of this stuff than talk about it. Is that fair? It's more interesting to show you. So we built a little demo system to kind of show you how you can take multiple microservices, and I have a bunch of them here. Okay? So we've used all the microservices frameworks and tools. So we've mentioned, this is kind of a session on microservices frameworks and tools. Here's your most popular ones: Wildfly Swarm, Spring Boot, Node.js, Vertex. Vertex is my favorite. But these are solutions that allow you to build an application very quickly in a very small, succinct way. Most of them have the fat jar deployment model, means they bundle the app server inside the jar, and you deploy that as a single unit, and you run it as java-jar and the jar file name. That's all you do to run it. So all you need on your application servers is a JVM. That's it. There's no web server there anymore. There's no web logic there anymore. It's just send the jar out, let the jar run. That's what makes this architecture more agile in some cases. Okay? But it also, with great power comes great responsibility. In this case, I'm going to show you the pattern of the browser making the connection. I know that screen is very small there. But in this case, the browser is the aggregator, and it makes the invocation to the 4 services. And I'm just going to make that's basically making the calls there. If I go to the API gateway, okay, it's making calls there. So in this case, the logic is on the server side as opposed to the client side. It's not on the browser side, it's on the server side. And then there's the chaining architecture. This is where some architects get really freak out. This is where you actually have dependencies. Service A calls B, calls C, calls D. But this is what you do in a microservices architecture, which is inherently distributed. The first rule of distributed computing is not to do it. But if you're going to go microservices, you will be distributed. In which case, you now start thinking in terms of circuit breakers. So let's show you the circuit breaker. Okay, I'm running Netflix Historics. That's the most popular circuit breaker open source. I need to ask Buck if he's still here, if he's going to open source his version, because it sounds like it probably work for .NET people. But so here's the circuit breaker. Let's see if it's running for me, okay? Yeah, so let's go here. If you notice the green number 1 right there, and the closed, the circuit is closed, we're all green, everything's operating normally. But what happens if we have a service go down? Let me kill this service right here. Okay, I'm just going in here, and we're going to scale it down. That's a Linux container I just shot and killed, so we'll go down now. Now watch what happens here. This is the interesting part. You mentioned fallbacks. When I click refresh now, notice it took a little time, and now Aloha is broken, and it gives me the fallback. 1 and 2 still operating great. But the business logic now is it says, what happens when something I depend on fails? And you notice to see the little yellow right there? Let me hit it again. All right. Sometimes it takes the launcher a little time to upgrade, so we had a timeout on that request. If you notice, these requests take a little time. Okay. Now watch what happens when I kick it over its threshold. We set it pretty low. If I got to do it fast enough, boom, that should be it. The circuit is now open, and watch what happens to that blue number. Those are short-circuited requests. I'm now bouncing off that guy. So just like it was said in the earlier session, if you already have a dead service, don't keep kicking it, right? That's what you do, right? That's what we do. That's what happens. This theory, by the way, came out of a book called Release It. Another great book you should read, Release It, by Michael Nygaard. He documented this like in 2005 because all his app servers kept eating all the connections, their connection pools, and then they brought down like whole airlines for the day, right? And this just happened not too long ago. But single point of failure, cascading failure happens, and if you have this form of situation, you can see that the circuit breaker helps me by bouncing off. Now, if the service gets healed, let's bring that Linux container back up. All right, so I've just requested for the Linux container to come back to life, the Docker container. This is a Kubernetes backbone with the OpenShift user interface on top of it. And again, this is all open source. I'm not showing you here anything that's not open source. Red Hat's all about open source, but you can see this service is a yellow ring because it's booting up and it's doing its readiness checks. Not only is the Linux container running, but the service itself is ready and responding, and that's when we get the nice blue. And this poor machine of mine is so hammered that it's taking a little longer than normal. But watch what happens here very quickly. Watch that right down there at the bottom. Closed. Circuit's closed. We're healthy. We're green. We're back to business. So the concept of circuit breaker is very critical in a distributed architecture. And by the way, Hystrix works with JDC drivers, file I/O, call whatever you want to call, and you can put the circuit breaker in between, and you get this cool monitor to monitor that as an example. Okay, we'll keep marching along though. Another thing that enables speedy production is, and he mentioned this also, like feature flags and things like that, but what I want to show you is a blue-green deployment. And in blue-green deployment, you basically have a copy of your production environment. So literally, you're provisioned for production twice. You have green and you have blue. And what you do is you update, you do the rolling update on the non-active one, you fail over to that one, and if it's all good, you stay there, and now you have the other as your hot spare disaster recovery, and that's the one you update next. This allows you to never have downtime, because worst case is you fall back to the previous one. So let's show you that real quick. This is a fun one. So, okay, if I gotta find everything here. Okay, we're doing okay on time? You guys tell me. So I'm gonna ping the API gateway. That's this guy right here. You notice it says green. So it says green right there. Let's go over here into the code. It's hard for me to read. I gotta put my glasses on here, I think. Okay, so see right there it says blue. Let's call that iTark. Okay, so there's what the code looks like. iTark right there. See it? I'm gonna hit save. Okay, this is a Java project. So I'm gonna go over here to my, there it is. I'm going to do my Maven package. I'm going to do my standard Maven build. Okay, you guys didn't think you were coming to see Maven build, did ya? All right, look at that. Maven build success. And I'm going to do my Docker build. I already have that set up here for OpenShift. This is my Docker build. So I'm taking my microservice, which is just a single fat jar, wrapping it with my Docker file, which is just a few lines as well, putting it in a nice liquid Linux container, putting a bow around it, and shipping it to production. But in this case, it's going to blue while we're on green. So green is still up, right? We're not impacting green. If I look over here, green is still responding, right? Even though blue is building and being deployed to production. Because we're still on green. Okay, let me go back up here. See, it still says green, right there. Okay, all green. But now, we think blue is ready to roll. We've done some additional testing, because we do testing in production now. You know that, right? That's the new way to do it. That's the microservice way, the fast way. But now I'm going to patch my route. We have the concept of routes. We can dynamically change the route. And I have it already loaded here to go to blue. And if all goes well, okay, if all goes well, see it says iTark now. We failed over instantly. And I have to refresh my browser, it's iTark. And I can go, oh man, bad push to production, crap, let's go back. Right? Let's go back to green. Boom. All right, back to green. So we're all green now. There we go. Green there, green there. All this is just doing is a curl script, right? Back to green. So that's the concept of blue-green deployment. This is the kind of infrastructure, the elastic self-service on-demand infrastructure I think you ought to have to really be successful in the microservices world. I can show you the CI/CD deployment pipeline as well. I have that all loaded here locally. But I'll show you one more. And this is actually one that Buck also touched on because it's even more powerful. And I do have it set. Hopefully it works. Okay, the Bonjour service is actually set for a canary deployment. So I want to show you blue, green, and canary. In the blue-green world, it's all or nothing. You're either blue or green, right? It's 100% one or the other. In the canary world, it's a sliver of the traffic that you decide to take over to the new one. see if it stands up, see if that canary in the coal mine sings. If the canary sings, we keep rolling traffic over to it till 100% there. If the canary dies, we roll back, right? And when you use Linux containers and an engine like Kubernetes, it's actually not that hard. So let's actually go to, the code. Let's make a little code change here. And so here's the Bollinger service. This is a Node.js service. And oh yeah, there it is. It says canary. Let's take that out, put iTarget there too. Okay. Boom. I'm going to go back to command line. You can, and this is all API driven. You don't have to use command line. You can use it all through REST API. I like command line. It's a Node.js app, so we don't have to do the main package, but we still have to do the Docker build. So let's do this Docker build right now. Okay. And let's do this while that's building. We've got to tell these folks to invest in a little higher resolution monitors, but there we go, Bonjour. So we're actually deploying Bonjour and running live transactions against Bonjour all right now, okay? Because we're set for a canary deployment. In other words, our current users are not impacted by the fact that we're literally doing a production push right this second. On the case, all on this VM I have running here, I have a whole cloud running here. But now, watch what happens with this one. This is fairly interesting. So I have 3 servers in production right now. If you look at this carefully, you'll see at the very end of the Bonjour actually has this odd-looking string. That is the host name for that code. Each piece of code, each microservice thinks this is running in its own physical server. That's how virtualized we are here. But they're just little tiny Linux containers, all running within a RHEL virtual machine, running on this Mac OS X machine. And to make that point, I'll show you I'm running actually here on VirtualBox. So this is just VirtualBox right here. I did dedicate 8 gigs of RAM to it because I have several other demos also running with this environment. But I'm running 3 web servers. We're hitting it. But let's do this. Let's spin up the canary. And just that act alone, 1 of 4 means I get 25% of the load goes to the canary deployment. And if all goes well, we'll get a little blue ring here. Again, my CPU is pretty hammered at this point. And then you'll see my Polar pick up. There you go. It's doing random load balancing now automatically for free across that new deployed service. It does have sticky sessions, so if you actually had live users already logged in, which things in their shopping cart, they would remain sticky. You want that. You want to lead them off slowly. But in this case, it fails over right away for a stateless service. And if I decide I want to roll it up a little higher, maybe I want to go 50-50, right? We're going to see 50% of the traffic on the old, 50% of the traffic on the new, and it just keeps rolling up. Let me, maybe for those folks on the other side of the room, maybe they're a little higher. And so, and then if I decide, oh, you know, I'm going to roll this back down. I don't need that thing right there. All right, let's roll it back down. And now we've taken the iTarget right out of production. My CPU is totally fried at this point because I've run this actually a lot this week. And all I do is close the lid, put it to sleep, bring it back to life, and it all still works. So the entire cloud I have running here still works even after setting the laptop to sleep. But now we're all back to Bonjour, the regular one. We roll the canary back out. There's a lot more I could show you in this category. We could spend a lot of time here, but you know, I just want you guys to think about these things because what used to be science fiction are really, really hard, really expensive, big, you know, F5, big IP hardware, crazy stuff we have to buy from IBM or whatever. It's all open source now because all those folks like Google, Netflix, you know, Facebook, they lived this pain. They went from a little tiny organization to a behemoth organization, and they learned these lessons along the way, and they've been kind enough to open source all the awesomeness they figured out along the way. Kubernetes is Google. Google runs 2 billion containers a week. I don't think you need to scale that high. And I'm running it on my laptop. I can't run 2 billion containers here because I don't have enough memory, but I'm running 20 on a laptop, 20 independent web application servers. And so this can be done in some amazing ways. You can learn the principles and patterns of blue-green deployment, canary deployment, how to do Docker deployments, things like that. And just to kind of maybe drive that point home, we'll kind of jump back into slide mode here. The instructions for how to do this is at bit.ly MSA instructions. I have recorded demos out there also. And you don't even have to make notes that are that substantial. All of my slides, I open source all my slides. If you look at this last link down here for bit.ly iTarget 2016, it'll take you to the deck, which is all open source. You can do a file copy, edit it, and deliver this presentation in your own shop. And then you can download the demo and run the demo yourself on your own laptop. This is how we live in a Red Hat open source land. We give it all away. Okay? totally out of time, right? Yeah. But if you guys have questions for me, I'll just step right outside here. You can ask me whatever you like. Hopefully you enjoyed this. Was this even remotely what you're thinking of getting? Yes?